So welcome to the walkthrough. It's November 2018 series for Edexcel Higher and it's paper 1, so non-calcs. Number 1, as you know with the laws of indices, when it's multiply you add the powers, so the power on top should become 5 and the power on the bottom, which is 3. Over means divide, so you subtract. Now don't forget that's not the answer because it wants the value of, so your job is to do 3 squared to get the answer of 9. But as substitution, don't forget whenever you are tackling a substitution question, rules of BIDMAS must apply. Work out the value of V, so V squared. Let's plug all these numbers in. We've got U squared. Any bits you can do as you go along helps you out. Added to 2 times A is -6 times S, -6 times 18, 6 tens, 60, 6 eights, 48, so we're taking away 108. That simplifies to give us 36. So for V, obviously +6 is the answer most people will give, but plus and -6 if you want to be that little bit of perfection. Make S the subject, so I always say leave the S term where it is. Get rid of everything else. So subtracting U squared from both sides. And then we need to divide by whatever is next to S because it's multiply. We divide. So we put the V squared minus U squared all over the 2 and the A, and we're done. Number 3, one of those over the top, quite a bit of work to do for this one, but it's not difficult, it's just lots of it. So a bonus of £2,100 is shared by 40%. So you work out 10% is 210. So 40% is 4 times that. So £840 goes between the 3 managers. So it's £280 per manager. The rest is shared between the 7 salesmen. So the rest, 60%, do a takeaway if you want, mental arithmetic if you want, but the rest is £1,260. That needs dividing by 7, so that's £180 per salesman. Okay, now if it's the rest of the bonus is shared equally, not that bit. If the bonus is shared equally, so if it's shared equally, £2,100 shared by 10 people, they'll get £210 each. So one of these guys says, I will get 25% more money. Well, he definitely gets more, it'd be £30 more. But the question is, what is 25% more? So if they're getting £180, if you want to add on 25%, 25% is a quarter. Halve 180, halve it again, so a quarter. So if the bonus is shared equally, he will get 25% more money. Well, actually, to get 25% more, they'd need to get £225 each. They actually would only get £210 each if it's shared equally. So it's a no. There's a 15% difference between all being shared equally and being shared as described in the question. Number 4, one of them rates ones. So straight away, as soon as you read the top line, you should be thinking 600, 120 working, 5 taps, working 120 minutes. There's 600 tap minutes there, whatever the unit you want to call it. And obviously we divide it by 3. They're nice, them questions, whether they're trickier numbers on a calc paper or not. State one assumption. So again, like all these wordy questions, don't overcomplicate for 1 mark. Basically, it's that all taps work at the same rate, or words to that effect. Number 5. A plane travels at a speed of 213 miles per hour. You haven't got a calculator, so that 213 seems a bit tricky. So the idea is 213 miles in 1 hour. That's what's going on. Now, as we can see, the answer is wanted in seconds. So let's replace 1 hour, 3,600 seconds. So what sum do we actually need to try and work out? Well, if work out an estimate, so we need to go for how long does it take for 1 mile? So we would need to do 3,600. How have I gotten from there to there? We've divided by 213, but it's an estimate, much easier to divide by 200. Off go the noughts, and we're left with 18 seconds. Mark scheme allows 16 to 20 inclusive. Is your answer an under or an overestimate? It's an overestimate because we've taken the speed of 213 miles per hour. We've taken it down to 200 miles per hour is what we've essentially done. So if the speed is rounded down, then the amount of time will be too high. So it's an overestimate for that reason. Number 6, your choice. You can either treble the top equation so that they've both got 3 next to the y, obviously plus and minus 3, or you could times the second equation by 5. Personally, I'm a big fan of keeping numbers as small as possible, so I always try and multiply by the smallest value. So although that'll take it up to 63, I'm going to treble the top equation because it keeps the coefficients a little bit smaller. It's just personal preference, really. 3y equals 63. The second equation stays as is. So we've made the y's have a 3 in front, but they're not 3's, they're plus 3 and minus 3. And as we'll know from our teachers nagging us, same sign, subtract. These are different signs, so it's an add. So we get 16x's, y's disappear, 72. So x is 72 over 16, not a nice round number, unfortunately. Divide top and bottom by 8. I'm saying one thing right. Divide top and bottom by 8. So we get 4.5 or 9 over 2. Let's take the top equation. We've got 5 lots of x. That's 22.5. Added to whatever y is, and it goes down. That means it must be a negative. And what's the difference? 1.5. Quite a few ways of doing that last step, but that's my preferred way. Number 7. One of those questions that really does put people off, but one thing at a time. Do the easy bit first. It's about area. You can see that. Do the easy. Area of the square. The square is 20 by 20. So 400 is going to be in the question somewhere. Then we do the quarter circle. That's ACB, this quadrant here. Now, if that circle was a full circle, its radius would be 20. So we need to do pi times the radius squared, but divide it by 4 because it's a quadrant, it's a 4. It's a quarter of a circle. 20 squared is 400 divided by 4. And because of the way that's phrased, don't try and do any 3.14 rubbish. Now, when we come to this semicircle, the radius of the semicircle is not 20. So to do the semicircle, we do pi times the radius squared, but it's a semi, not a quadrant, not a quarter, so we're only halving this. And that's 100 over 2, so that's 50 pi. So we've got the 400, let's give myself a bit more room. The area of the shaded is quadrant minus semi, which in other words is 50 pi, divided by the whole thing. That was 400. And as we can see, those cancel out. 5 over 40 is 1 over 8. And it all works out nice and friendly in the end. Just didn't start that way. 8a, one of them definite ones to learn, just like sine 30 and so on. Tan 45 is 1. They give you another little fact here, because, yeah, people always think, oh, SOHCAHTOA can't come up on a non-calc paper. Yes, it can. With sine 30s, cos 60s being the most common. They could even give you one with sine 60s, because root 3s are just becomes a surds question. So, labels, as I always do, that's the hypotenuse which I want. From the 60, that's the adjacent which I'm using. The opposite is useless, so this is a ha question. We want the hypotenuse, so it's a divide. We do adjacent, which is 4, divided by c, which is cos of the angle. Cos 60, we're told, is a half. 4 divided by a half means 4 times by 2. We get 8. Number 9, done my usual cheating, because no one wants to see me take hours. Trust me, it would be. Alright, so I've drawn them on already, because these are also quite easy. Let's also be blunt about that. So there's 48 trains, so find your median at 24. So that's why the line in the box is there. Find your lower quartile, known as Q1, by going 12 into it. Mine doesn't line up perfectly because I've cut and pasted this from my worked answers. Then 36 is 3/4 of 48, and that's how you line them all up for a 3 marker. And you also know what's coming. Why have they given you another one? It's for comparisons. Now, I've written them all out in full on my worked answers, but with it being worth 2 marks, make sure you compare the medians. So as you can see, on average on a Monday it's 10, a Tuesday it's 9, so you can say on average Mondays is higher. And also mention the spread, both the interquartile range and the range. They're both longer on a Monday than on a Tuesday, so you can make the statement that the delays are more varied on a Monday as well. I'll just sneak a peek at what Mary says. Mary says on a Tuesday the longest delay was 33, so she's obviously right in that. This means there must be some delays between 25 and 30. Now, at the end of the day, she's probably correct. It's unlikely that there won't be any between there. But does Mary have to be right? Does there have to be? Well, I'm afraid there is no evidence for that. So what you could say is all that there's 48 trains represented in that data. So there are 12 trains represented there. So my argument is all those 12 trains could have been 31 minutes late. It's possible. It's obviously virtually impossible, but it is possible. But I've gone with, on my worked answers, I've said the following phrase: no, these 12 trains could be any delay from 17 to 33. They don't have to be evenly spaced. They don't have to be anywhere. They could literally all be 20. There could be 11 of them could be 20 and one of them could be at 33. Very possible, it could easily be the case. Don't obviously spend as long as I've just spent waffling. Don't waffle for that long. Number 10, x minus 1 on top. X minus 1 cancel on the bottom. That's all you need. No need to expand the bracket. It's only worth 1 mark. And this one doesn't look like the difference of 2 squares because there's not a square number here, but there is if you take a 2 out. A very common practice there. So the 2 comes to the front, and then you've got a square number and a square bit of algebra with a minus in the middle. So it's 5 plus y and 5 minus y. So yeah, it is a difference of 2 squares, just not the usual way. Number 11's extremely waffly. I'll assume you've read it already, or you can pause the screen and have a read of it yourselves. The fact is, it's all about proportion. And in proportion, you could do this a percentage way. You could do this by picking some numbers. You could just assume there's, 100 grams for a pound and do it based on that. You can pick your own numbers and so on. Now, I do a mixture of those in terms of I like using the number 100. So the idea is the proportion. In other words, you can write proportions as ratios, as fractions, and so on. I go for the fractions. So for Jack, the proportion, in other words, the cost, the 125 out of the original of 100 is the same as Sardu says, it's 100, but it's reduced to a certain amount. Now, we don't know, all right? She said reduce the price, do not change the amount of cereal, so there's the price and there's the amount. Now, if you rearrange this, you get the answer 80. All right, but it wouldn't be an 80% reduction. It would be reducing it to 80 of the amount, the 100 grams of cereal, for example. All right, the 100 pence, reduce the price, not change the amount of cereal. All right, so this is a volume increase. This is a price decrease. Now that's down from 100 to 80. That's a reduction of 20%. 20 pence in the pound. All right. As I say, there's lots of ways of doing that. I've tried to do that the quick way. Probably not explained it the best, but feel free to pick some numbers and trust me, it will work out a treat. I've just done it the smart Alec way. For 3 marks, it's quite quick for a 3 marker. Number 12. It says you must show your work and you don't have to give reasons, so you can just crack on with this one. Whenever you are doing a circle theorems question, always look for isosceles triangles. Okay? So, the first thing is, if we've got 56 here, you've got this line, you've got a triangle. If that's 56, thanks to the alternate segment theorem, that's 56 as well. Thanks to this arrowhead here, the angle at the centre is half the angle at the edge, the angle on the circumference is half the angle at the centre. And now thanks to this here, we've also got base angles of an isosceles triangle. They must be equal. So these two spit out as 34. Now, I will just stress I've gone about it one way. Another way of getting that 34 would be to use the fact that that tangent to radius was 90. So 180 minus 90 minus 56 would also have gotten that 34 as well. Okay, so you could have gone about this a different way to what I've just explained. But ultimately, it's wanting how big is CAO. That's that angle there. So like I've said, several ways of getting to that point. CAO, 180 minus 56 minus 34 minus 90. However you get there, several ways of cracking that nut, but 31 is the answer. Number 13, so obviously it's a different size, so it's an enlargement. I'll let you write it all out in full. It's going from A to B. So I look at that distance there, and that is 6. I look at that distance there, and that is 2. So it's been divided by 3. Or in other words, the scale factor is not just a third, because it's getting twisted inside out, it's negative a third. Now, how you find the centre, join up corresponding vertices. So there we go. And let's join up the right angles. There we go. You could have picked the other one. It wouldn't matter, because guess what? They all cross at the same point. So any 2 will do. The centre is the coordinate 2, 2. And there we go. Number 14. So when you've got a fraction to a power, you can do the top and the bottom separately. And power of 3/4, the way I always explain it, top number makes it bigger, bottom number makes it smaller. On a non-calc paper, you don't want to be working out 16 cubed. You make it smaller first. The 4th root of 16 is 2, and 2 cubed means an 8 on the top. Do the same to 81. The 4th root of 81 is 3. What's 3 cubed? 27. Looks easy when you break it down to one step at a time. B's quite a weird one, but it's just going through the thought process of what's 3 to a power? How do I write 3 as a 9th? Well, I need to square it and flip it upside down. So we've got A as being negative 2. What about B? Well, 9 is 3 squared, and root 3 is 3 to the half, and these are next to each other, which means times. Sorry, which means times, which means add the powers. They're all positive, so it's plus 2.5 or 2.5. And finally, for the third term, it's also power of a half, but it's also a negative power because it's 1 over the reciprocal. And so the C, the power, is minus a half or minus 0.5. And look what happens when you add all these up. They all cancel each other out. It's a 0. What a pain. You know, quite nice in the end, but yeah, one of them pain in the backsides. Number 15. Don't forget with these surface area and ratio of heights and stuff, it's all about when you've got, let's just draw a little doodle. If you've got a rectangle, if you double a rectangle's area, if you double a rectangle's length and height, you quadruple its area. Or in other words, it's 2 squared. So to go from linear scale factor to area scale factor, it's scale factor squared. To go linear to volume, it's cubed. And to go backwards, it's square roots and cube roots. So let's take this. These are areas. So if we want to go backwards, these are areas. We want to take it down to linears. we must square root them both. So 2 to 5 is the linear scale factor of A to B. Now, when we do B to C, their volumes, that's them, they need cube rooting. So that's 3 to 4. So now down here, we're into linear scale factors. It'd be nice if we could link them in the middle. Well, the lowest common multiple of 5 and 3, we get 15. So we times the by 3, we times that by 3, times this by 5, do the same over here. We now have them linked, so we can write A to C is 6 to 20. It wants simplest form, so we need to divide them by 2. And we get 3 to 10. Long-winded, yeah, but when you know the process of squaring, square rooting, practice makes perfect, and they actually become quite quick. So for number 16, one of those standard questions, you know they come in pretty much every set of papers, so definitely always spend some time revising these. Let X be what you're given, that's the standard starting, and wherever the recurring bits, you need to budge them up so that they immediately follow the decimal point, and then budge them up again so that you get the same repeating pattern. That's how I always like to go about it. And to do that, you need to budge them up twice, make 256. That means times left and right by 100 to get 1,000. Now, I know some teachers tell their students to always do 10, 100,000 and then see where you can get them to cancel out, and that's fine. Stick with whatever works. And now comes a takeaway, bottom takeaway, top. It's 156 take away 2. And all of the other nonsense cancels out. And after the algebra, the next bit the examiners want to see is that you've gone to this stage to convert it to a fraction and then finish the job by cancelling down. They've given you the pointer in the right direction. Use it. Number 17. Strange one, this. All right, strange sort of quadratic question. Loads of ways of going about it. You know, the idea that they've told you that that is 5, 0. Now, if you know that it crosses at 5, you know that x minus 5 is one of the brackets, so you could go about it that way. I've gone for about it a different way, which is, if you know 0 minus 5 there, that number on the end is b. So we have got the fact that the equation is y equals x squared plus some x's minus 5. All right, so that fact there gives you that fact there. You could sub in the 0 and the minus 5. It would still give you what you want. But then we use this other fact. So we've got this equation. Let's use the other coordinate. Let's replace the x with 5 and the y with 0. And as you can see, if you add 5, take away 25 from both sides, you get negative 20 equals 5a. Or in other words, a is minus 4. So you're pretty much there in terms of you've got the equation of the curve. Y equals x squared minus 4x minus 5. Now you could factorize this. If you'd have gone about it the solutions way, found that and that. The vertex is halfway between them. That's one way of going about it. But in terms of revising the standard route, turning point means complete the square. So we halve the number next to x, square it and take it away, so -4 minus 5 gives us -9 on the end. Horizontally, we change the sign. Vertically, the sign stays the same. Strange question, that. Number 18. So I'm bravely going to try and do this live and not have cheated. So x minus 2, the graph of y equals x squared looks like that. The graph of y equals x minus 2, all squared, it moves right 2. So that's what we need to do. So that must move right 2. This must move right 2. The solutions must move right 2. And its vertex must as well. So as long as you've got them plotted, you're probably going to get the marks as long as you don't do anything too stupid here. Mine'll do. It's a nervy one, but it'll do. This one, as you can see, the graph has been reflected in the y-axis. A reflection in the y-axis means you take the x, only the x, and you replace it with a minus x. The minus does not go in front of the whole function. It's in front of the x alone. And then, as you know, with these 1 markers that aren't waffly 1 markers, you either know them or you don't. All right, and if you didn't, that's where some revision needs to kick in. Number 19, do not get put off by functions. If your algebra is strong, your quadratics, your expanding brackets, do not quit on functions. Show means do. So we've got to work from the inside out. So we need to take the f of x function and basically sub it into g, into there. So the 2, the brackets, and the -1 remain unchanged. The x needs replacing with the x plus 1 all squared function, because that's really what's going on. Show means, well, expand some brackets, simplify some stuff, and hope it turns into this. So let's do it. Square in brackets, square the first, square the last, times them together and double it. We've got a +1 and a -1. In other words, we've got 2x squared plus 2x squared plus 2x. We can take another x out, leaving us with just an x on its own there and just a 2 on its own there. So why it's only 2 marks, it actually simplifies quite quickly. Part B, 2 main ways of going about this. You could either rearrange the function g to find the inverse function, or I've done it the way, let the actual function equal the 7. Because the idea is they're asking you to put 7 into an inverse function. Well, don't forget, the input of a function gives you an output. Well, the inverse function, they flip around. Input becomes output, output becomes input, domain becomes range. That's how it will be phrased in A level. So you can simply, there's the output. The output of the function is the input of the inverse function. Yeah, it's a bit gibberish, but it is what it is. So we can expand or divide by 2. It's entirely up to you. I've gone for expand. Add 2 to both sides. divide both sides by 2. 9 over 2 or 4.5. Number 20. First thing to note is root 18. Let's not forget that root 18 can be simplified. Root 18 is root 9 root 2, or in other words, 3 root 2. So the top part is really 3 root 2 plus root 2, in other words, 4 root 2. So on the top, we've got 4 root 2 all squared all over root 8 minus 2. And we need to multiply that, and we have to change the sign. Now, when you do 4 root 2 times 4 root 2, you get 16 root 4, or in other words, 16 twos, or in other words, 32. So the top part gives us 32 root 8, and we'll simplify the root 8 later. You could have done it straight away, but I just did one bit of simplifying first. I'll simplify the root 8 at the end. You could do it whenever you want. And we get 32 times 2. So that gives us 64. On the bottom, root 8 times root 8 is 8. Minus 2 times plus 2 is minus 4. And the inside loops don't need to bother with. Let's tidy up the top. Don't forget root 8 is root 4 root 2. So that's root 8 really. So 32 lots of that means I've got 64 root 2's on the top. And we've got all over 4 on the bottom. Everything now looks nice and simple. We can do 64 over 4 and 64 over 4. And that's exactly what we were being told to show. Take the 16 out and you're left with 1 plus root 2. And you could have done that in any order you wanted to. As long as you get there, it's all good. So question 21, I think an extremely tricky vectors question. If you have a look at my worked answers, I did a lot of explaining on there in terms of, did a load of working out. Hopefully I'll try and reduce the amount of working out here, but I'll do a lot of the explaining out loud. First of all, make sure you get all the wordy stuff onto your diagram. M is the midpoint, so they're halves. O to A is 8, get that on, and the direction, same there, but I'll take it off the diagram so I don't get it confused with the N. 3 to 2 means that's 3/5, and that's 2/5. Work out the ratio O to N, N to B. Yeah, not straightforward, and it's 5 marks. You can tell it's a stinker, folks, but let's go about it one bit at a time. Let's write down AB, because whenever you've got a triangle, it's nice to know all 3 sides. So that is a starting point, and it's one of those, if you don't get all the way through this question, and you avoid 0, can you get 1 or 2? Can you turn those 1 or 2 into 3 or 4? It's one of them. All right, don't forget you don't need to nail every question to get the high grades. All right, you can drop marks. It's not a crime. So A to B, going that way, is we do minus A plus B. I'll put the positives first. Then let's look at O to M. To go from O to M, we go to A first of all, and then we go a half of what we've just done. So we add on a half of B, and a half of negative a. And if we tidy that up, we've got a half of both. We've got a half of b and a half of a. That's my first bit. Now let's look at this straight line going from a down to n. Right? A to n, well, can't quite get there because I don't quite know. Let's just look at a to p first of all, because that's stuff that I actually know. Going from a to p will be minus a and 3/5 of the O to M line, 3/5 of what we've just done. 3/5 times a half is 3/10. So let's write them all out as 3/10 of A and 3/10 of B. And because it's complicated, let's tidy it up. We haven't got a calc, so be careful. -1 means -10/10. Plus 3/10 is -7/10 of A plus 3/10 of B. Now the key here is, if we want to get this distance here, O to N is what we're after. If we look at O and get to N, we need to go to A first of all, which is that, and we need a multiple of A to P, because A to P gets you to P, doesn't quite get you to N. So it's some multiplier of this nonsense here. But here is the key. To go from O to N, it's only in terms of B. That's the key bit. There cannot be any A's. The A's must cancel out. So let's only look at the A's. This A has a 1 in front of it. This A has -7/10 K in front of it. One's a plus, one's a minus. They must cancel out. They must be equal. Hopefully we're there. And so the idea is, we don't need the minus act because we need them to disappear. So by putting them equal to each other, we want them to be equal. We wanted them to add together to equal 0. So times by 10 divided by 7, we get that the K value must be 10/7. So let's take that forward. If K is 10/7, let's look at the B's. K is 10/7. B is 3/10. The 10s cancel and we get 3/7 of B. And that's the logic. If there's O, if that's B, and that's N, O to N counts as 3 out of the 7 parts of that line. N to B must be 4 parts of that line. Hence the answer, the ratio is 3 to 4. Now I hope that explains it. It's a tricky one, it's a tough one to get across. Have a look at how I've done a bit more written down on my worked answers, but feel free to post a comment if that's too happy to do another explanation. I have done quite a few vectors questions explained on my channel. I think I'll add this one and spend a longer time analysing what's going on this one. But there we go, time to move on. For the final question, if you think it's a bit easier in terms of what it's on about, it's just tricky algebra really. So number 22, whenever you've got a question like this, you can see that we've got, two things going on. Start out, make a list, make a table, get it organised, green pens and blue pens. There are 3 more blue than green, so however many green there are, there's 3 more there. There are more than 12 pens in the box. We'll come back to that. 2 pens, the same colour. Right. Let's do the probability of green added to blue. Now, the probability of getting 1 green is however many greens there are, divided by however many pens there are in total. That needs to be multiplied. There's now 1 fewer green pen. There's now 1 fewer pens. Let's move on to blue. Similar approach. It's going to be the same nonsense on the bottom because the same principle is going on. It's what's going on top. How many blue pens are there? Well, initially there's x plus 3, and then there becomes 1 fewer. In other words, x plus 2. Let's tidy that up and then bring into play the other bit of information. So, whatever's going on the bottom, let's expand. So, because they're the same, so we can just do that bit first. X squared minus x. Top times top over here gives us x squared plus 5x plus 6 all over, and let's expand the bottom, not forgetting they're quadratics. So we've got 4x squared plus 10x plus 6x plus 6, and that must equal the 27 over 55. Now let's not forget, because I've got to scroll down, give myself a bit more room, greater than 12. So, on the top, I'm going to tidy up the top and times everything by 55. So, I've got 55. In fact, hold on, let's tidy it up. Let's create a bit of room. X squared plus x squared is 2x squared. Minus x plus 5x is plus 4x. And as you can see, everything on top is even. Everything on the bottom is even. So I'm going to multiply through, but only by half of these. So let's times everything by 55. So 55 times 1x squared. 55 times by 2x is 110x. 55 times by 3 gives me 165. 27 multiplied by all this, but don't forget again, they've all been halved. So 27 times 2x squared. 27 times 5x. 135. And 27 times 3. 81. Thankfully, when we subtract 54x squared from both sides, we're getting a nice quadratic. Take away 135x from both sides. taking away 81 from both sides. We're not just getting a nice quadratic because there's no number next to x squared. We're getting one that factorises, really friendly. Minus 21 minus 4. X equals 4 must be rejected because we can't have 4 green pens because that would lead us to having 7 blue and therefore 11 in total. We're told there's more than 12. That's why we were told that. So there must be 21 X's. It did say work out the number of green pens, and green was X, didn't say blue pens. Always take care of that stage. There's 21. So, lots of algebra, but not the worst algebra. Certainly one of the worst vectors questions preceding it. But there we go. So I really hope that's helped. I'll see you on paper 2.